Welcome to sixth grade math tools. In this math workshop, we will take a deep dive into what math tools, the manipulatives and the representations, we should use with our sixth graders to impact their understanding of core mathematical concepts. We will explore why we should provide math tools for our students, what tools to provide, how, and when. Whether you are an educator new to teaching sixth grade, a homeschool parent teaching your mathematician, or an experienced sixth grade teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. These are the 5 domain areas for mathematics for sixth grade: ratios and proportional relationships, the number system, expressions and equations, geometry, probability, and statistics. Let's talk about why we should provide math tools for our students. We agree with this quote from Paul Halmos: "The only way to learn mathematics is to do mathematics." We believe that providing math tools for students to use in math class offers a wide range of benefits, transforming abstract mathematical concepts into concrete, understandable experiences. Many math concepts, like fractions, place value, or algebraic equations, are inherently abstract. Math tools provide a tangible way for students to see and touch these concepts, making them more concrete, making them easier to grasp and to remember. Providing hands-on experience helps bridge the gap between abstract mathematical ideas and real-world scenarios. Math can sometimes feel dry or intimidating. Manipulatives introduce an element of play, exploration, and interactivity, making math lessons more engaging and fun. Increased engagement often leads to a more positive attitude towards math, fostering a lifelong love of learning and reducing math anxiety. Not all students learn in the same way. Manipulatives cater to kinesthetic, hands-on, and visual learners, providing multiple pathways to understanding. They're particularly beneficial for students who struggle with traditional abstract instruction, including students who have been performing as low achievers, students with learning disabilities, and English language learners. By building a strong foundation in conceptual understanding through manipulatives, students are better prepared to tackle more complex mathematical concepts in the future, including those in algebra and beyond. In grade 6, instructional time should focus on 4 critical areas. 1, connecting ratio and rate to whole number multiplication and division, and using concepts of ratio and rate to solve problems. 2, completing understanding of division of fractions and extending the notion of number to the system of rational numbers, which includes negative numbers. 3, writing, interpreting, and using expressions and equations. And 4, developing understanding of statistical thinking. Let's take a deeper dive into exploring what math tools can support these 4 critical areas of sixth grade math. Number 1, ratio and rate models. Several models help students connect ratios and rates to multiplication and division, including equivalent ratio tables, tape diagrams or bar models, double number line diagrams, and equations. These models allow students to visualize and reason about relationships between quantities, making it easier to solve problems involving ratios and rates. Here's a more detailed look at how these models work. Ratio tables. Ratio tables are a visual way to organize equivalent ratios. They help students see how different quantities are related by using multiplication and division to find missing values. Tape diagrams or bar models. Tape diagrams use a visual representation to represent quantities. They help students understand the relationship between parts in the whole, making it easier to solve problems involving ratios. Double number line diagrams. These diagrams use two different number lines to represent the two different quantities with different units. They help students visualize how quantities change proportionally, making it easier to solve problems involving rates and unit conversions. To support sixth grade students in reasoning about multiplication and division to solve ratio and rate problems, following manipulatives or math tools or representations can be effectively used. The two color counters. Excellent for representing parts of a whole and ratios, and for demonstrating how ratios can be scaled up or down. For example, a ratio of 2 red to 3 yellow counters can be easily extended to 4 red and to 6 yellow. Connecting cubes also could be called snap cubes or unifix cubes. Building ratio trains. Students can create trains of connecting cubes of different colors to represent ratios. For example, 2 red cubes connected to 3 blue cubes for a 2-to-3 ratio. This visually demonstrates the relationship between the quantities. Scaling ratios. By adding more sets of the initial ratio, students can physically see how equivalent ratios are formed. For example, 2 sets of 2 red and 3 blue cubes create a 4-to-6 ratio. Comparing ratio. Students can build 2 different ratio trains and compare their relative sizes. Cuisenaire rods. Similar to connecting cubes, Cuisenaire rods of different lengths can represent quantities in a ratio. Their varying lengths also naturally lead to discussions about scaling and relative size. Attribute blocks or shapes can be used to create sets with different attributes, the color, the shape, the size, and then discuss ratios based on these attributes, the ratio of red blocks to blue blocks or circles to squares. Number 2, those positive and negative number models and math tools. Several models can help students learn about positive and negative numbers in sixth grade. These include number lines, manipulatives, again, like the colored chips or the two-sided counters or the unifix cubes or linking cubes, and real-world examples like altitude or temperature. Number lines. Number lines visually represent numbers and can be used to demonstrate addition and subtraction of integers. Students can visualize moving along the number line to add or subtract positive and negative numbers. Number lines help with the understanding the concept of 0 as a reference point and the relationship between positive and negative numbers. Manipulatives, like those two-sided counters or the linking cubes, can be used to represent positive and negative numbers as well, with one color representing positive values and the other representing negative values. Students can physically combine and remove chips or blocks to model addition and subtraction of integers. This hands-on approach can help students develop a concrete understanding of integer operations. How about real-world examples? Using real-world examples can help students connect the abstract concept of positive and negative numbers to their everyday experiences. Examples like altitude, above and below sea level, temperature, above and below 0, or financial situations, savings and debts, can make the concepts more relatable. These examples can help students understand the meaning and application of positive and negative numbers in practical situations. Number three, those expressions and equations, models, and math tools. In sixth grade, the focus shifts to a deeper understanding of division of fractions and expanding the number system to include those rational numbers, those integers, those positive and negative numbers. Here are manipulatives or math tools and representations that can effectively support students in this area. Algebra tiles are colored blocks used to model and solve algebraic expressions and equations. They help students visualize abstract concepts like variables and constants. Visual fraction bar models or drawings. This is highly effective for showing division of fractions. Students can draw rectangles to represent each fraction. This leads directly to the invert and multiply rule. For example, you see on the screen the yellow and the green. For 2/3 divided by 1/2, we can draw 2/3, which we shaded yellow, and 1/2, which we shaded green. And the question we're trying to answer is how many groups of 1/2 are there in 2/3? And by examining our drawing and comparing the amounts, we can arrive at the answer that there are 1 and 1/3 1/2s and 2/3. We can check this by using the invert and multiply. We can change 2/3 divided by 1/2 to 2/3 times 2, and we get 1 and 1/3. Linear models or number lines, representing fractions as points or links on a number line. Division can be seen as how many jumps of size x are needed to cover the length of y. Two colored counters. So useful for understanding integer operations within expressions, especially when dealing with positive and negative coefficients or constants. Those connecting cubes can represent repeated addition for multiplication. For example, 3 groups of x can be shown as 3 stacks of x cubes. Attribute blocks can be used for classifying and grouping, which can be extended to recognize like terms based on shared attributes. Number 4, statistical thinking. Sixth grade students develop statistical thinking by learning to recognize statistical questions, understand data variability, and summarize and describe data distributions. Here's a breakdown of models, math tools, manipulatives, and representations that support this learning. Real-world context and scenarios. Presenting data in relatable situations like student heights, favorite colors, survey results on screen time, helps students connect statistics to their lives and understand its purpose. Data collection simulations using dice, spinners, or online random number generators to simulate data collection helps students understand the concept of randomness and variability before collecting real-world data. Counters, cubes, useful for representing individual data points, especially when dealing with smaller data sets or when introducing concepts like mode and median. Measuring tools like rulers, tape measures for collecting numerical data like height, arm span, or pencil length, leading to discussions about variability. Sticky notes or index cards for creating informal data displays. For example, the human dot plots, where students stand in lines representing data values. Here are the top 5 comments we get from teachers on why they don't use math tools with their students, especially upper grade elementary teachers. 1, we don't have time. 2, I don't know how and why to use them. And number 3, probably the most popular, my students can't handle it. 4, I didn't learn that way, so why should my students? And hopefully, this math workshop helped you with the second comment, providing the rationale for the how and the why. We respect that you are the professional in the classroom and that it is your decision on how to provide the best instruction possible for your students. We want you to consider for comment number 1, we don't have time, that your students' time spent truly understanding math concepts through the use of math tools leads to deeper understanding, memory retention of the math concepts because they really understood the math idea. And if students don't understand why they're performing math steps or following procedures, it's very likely they will forget what they're doing or how to do it or why they're doing it. Meaning next year, they're not going to remember what they learned the previous year. So they're just going to have to keep relearning. It also generally leads to a lot of mistakes. So our gentle response to the first comment is, how can you not take the time for real learning and understanding? We encourage you to watch this math workshop again and share it with a colleague. We know that teaching is so much easier when we have the support working alongside awesome colleagues who are committed to collaboration, sharing, and participating in this journey of education together. For the third comment, my students can't handle it, the next slide will offer tips for successful implementation that teachers have used. For comment 4, I didn't learn that way, why should my students? Our response is that research shows that most learners, and that's adults and children, learn best through tactile, hands-on, and visual experiences, especially in mathematics, where concepts tend to be very abstract. And I didn't forget number 5. They can't use the tool on the end of the test. So why should I bother during the year? Ooh, we hear this one a lot too. This is true. Good point. It is true. But hands down, teachers across the country have found if they allow their students time during the year to deeply learn the mathematics in the curriculum with math tools, by the time the end of year test comes around and the math tools are tucked away, the students have gained the true understanding of the math concepts that they can be successful answering questions on a test about that mathematics because using the math tools during the year opened up that depth of true understanding. Here are those tips for successful implementation of math tools that I talked about previously. Number 1, give students explore time every time. It's just maybe 2 minutes. Set a timer and tell your students, we're about to use this object as a math tool, but first, here's your 2 minutes of explore time. It's your time to check out this tool before we use it as a math tool. You will find that students will appreciate this explore time to see what the tool feels like, looks like, what it does. Then they can focus when you share, all right, now we're going to use this as a math tool. That leads us to number 2, setting clear expectations. Before ever passing out a math tool, share. This is how it can and cannot be used. For example, those geo boards and rubber bands. Oh, first thing we're going to say is rubber bands will not be flying across the room. If they are, you will lose whichever student chooses to participate in that behavior, you will lose the privilege of using that math tool that day. And we know kids don't like that. They want to be participating with the tool. They don't want to just be watching the rest of the class participate with it. Number 3, modeling usage. This is how we're going to use the tool. And number 4, consider the options that work best for your budget, your space, and your students. Do you want to provide math toolkits for each student where items inside rotate over time and students have choice? You could have a classroom helper job to restock the math toolkits regularly, Or would it work better in your space and with your budget to have a math tools area in your classroom with math tools in plastic bins? Possibly consider having table groups or individual student amounts in baggies, whatever works best for your situation, your students, and the activity. My hope is that you found this welcome to sixth grade math workshop helpful in supporting you and your sixth grade students with math tools. If you want more support, I invite you to join our sixth grade math workshop community for lots more support. When joining this private community with other sixth grade educators, you will gain access to a collection of math workshops which take a deeper dive into understanding these sixth grade math standards and the math tools that you will want to provide for your students. Monthly throughout the year, you will receive engaging hands-on activities dealing with all of the math tools mentioned in this video, lessons, games, and more to support the sixth grade math standards. You can find more information on how to register to join the sixth grade math workshop community on our website on the grade level resources page. Thanks for your time, and we hope you have a great year.